charges repel while unlike charges attract each other. Like, for example, there is the like charged body, and a positive and positively charged body will repel, and negatively charged bodies will repel, but a positive and a negatively charged body will attract each other, right? So one is this thing, and this is the most common one. You have seen this 1,000 times like that. I don't want to comment on this, but now one thing which I want, if it is attraction or whether if it is repulsion. Attraction and repulsion, they both are what? They are forces. Force. Repulsion is a force and attraction is also a force. So the question is that why repulsion and why attraction? For example, if you have a positive charge, let's say Q1 for example, and if you have a negative charge, let's say Q2 and Q1, then the question of attraction, why attraction? Because as I told you that charges is the basic or the fundamental attribute of matter which cause repulsion or attraction. How is this thing happen? Remember, with every charged body, for example, if you have this is a kind of body, for example, this is a glass rod and this is a plastic rod. It is a positively charged and it is a negatively charged rod, and they both attract each other. For example, there is a force of attraction on them. F, this is 1 on 2, and this is, for example, 2 on 1. Later on I will be explaining this. Now, where does this electrostatic force comes from? Which the 2 on 1 same as 1 on 2, a kind of electrostatic force of what? Attractive force only. Here in this case. Now, where does this attractive force comes from? It is because of the fact that every body, charged body, is surrounded by its own field. For example, a positively charged body, so there is an electric field around this body. And similarly, there is an electric field around this body also, due to the negative charge on them, and here due to the positive charge on them. So when these two fields interact with each other, they give rise to the electrostatic force. So where the electrostatic force, where does this electrostatic force comes from? Whether repulsion or whether the attraction, it comes from where? It comes from the point where when the two bodies are brought closer together, so that when their electric field interact with each other, that electric field give rise to electrostatic force. Either attraction or repulsion depends on the type of charge on body. One is this thing. In the same way, just as the gravitational force between two massive bodies, when you bring two massive bodies together, then the gravitational pull between them arises due to the interaction of their gravitational field. So in the same way, the electrostatic force arises because of the interaction of the electric fields of the two charged bodies. When they interact, there will be electrostatic force. So that is a second point. The third point here is the third characteristic or property of the charges is the conservation of charge. The conservation of what? The conservation of charge. That is, charges are neither created nor destroyed, but they can be transferred from one body into another body. However, the net or the total charge on the body will remain the same. For example, look, if you rub two material together, for example, look, if this is a kind of silk cloth, and let us suppose, for example, if this is a glass rod, let us suppose, for example, initially, if it has 100 coulomb of charges, for example, coulomb is the unit of charge, and later on in this lecture I will be explaining what is 1 coulomb of charge. If you have 100 coulomb of charge here, and let us suppose, for example, initially here you have the charge on this body, for example, look, you have let's say 50 coulomb of charge on this glass rod. After rubbing material together, then let I call the cell, when you rub the glass rod or the plastic rod with the silk cloth, what happens? This cloth, it has 100 coulomb of charge in the beginning. This has 50 coulomb of charge. For example, this is neutral and this is neutral. The total, what is the total charge? Here is 100 coulomb. Here is what? 50. So before rubbing these two material together, what is the total charge? 100 plus 50. You have 150. This is before rubbing material together. Before rubbing the material together. After rubbing together, let us see that what is going to happen when you rub together. The charge is balanced. For example, if the silk cloth acquire a positive charge, let us say, for example, it require a positive charge like this. So what does this mean? That it lasts electrons. How many? 1, 2. This is what? Total 10. And definitely as a result which this require a negative charge. Like this. 3, 4, 5, 6, 7, 8, 9, 10. This require a negative charge. So what happens? That this last, so what actually here you have now left here with 90, but here you left with what? You left with 60. And when you add 90 plus 60, what is the answer? The answer is again 150. This is after you rub the material together. So when you rub the glass rod or this plastic outcome with a silk cloth, then what happens? Both bodies are charged together, right? But the total charge remain the same as you see here. So charges are neither created nor destroyed. This is why I told you the word produce is not a good word. Charges can be transferred from one body into another body. This is another characteristic, right? That we have one like this one. The fourth property that the sure test, attraction is the sure test for detecting charge on body. Attraction, oh sorry, I'm so sorry, repulsion is the sure test. Repulsion is what? Is the sure test for finding charge on bodies. You cannot you cannot trust attraction to find what? To find the charge on body. The sure test will be repulsion. If you see the two bodies repulse together, then it means that the bodies have charge on them. For example, why I say that repulsion must be a sure test? Because we cannot trust attraction. Now why? Because you just see, these are the pieces of the paper in my hand, and you see this marker. Look, do you see any attraction? You do not see any attraction. There is no electrostatic force. Why? The pieces of the paper neutral, and this marker is also neutral. Now I use the phenomena of electrostatic induction as I told you earlier. Now definitely you see the marker is charged. The pieces of the paper were neutral. There is the fan on, so therefore it is not doing it. Look, you have seen it. It is attracting the piece of the paper as you have seen. So now, you know, they were electrically neutral before, right? And still it shows sign of attraction because of the phenomena of this electrostatic induction. This is why that attraction is not a sure test to identify the charge on bodies. The only sure test is repulsion. So if you really want to know that whether the bodies have charge on them, so repulsion will be a sure test. Don't trust attraction, because seeing is believing. I show you this thing. The fifth property, the most important point, that is very, very important, that is the quantization of charge. The quantization of charge. That is, the charges are quantized, right? Charges are quantized mean that the charges are the multiple of a fixed number or a fixed value. Sometimes we call the charge on electron. That it is the multiple of this number E. Here E represents the charge on what? The charge on an electron. And you know that the charge on one electron is usually 1.6 into 10 raised to the power minus 19 coulomb. Right? So the charges on the body will always be integral multiple of this number. Remember, right? That is, you can have the 2E charge on a body, you can have 3E charge on a body, you can have 4E charge on a body, but it can only be integral multiple, not half integral multiple or like that, or a fraction. The question is why? Because, for example, if I tell you, let's say that there is 2 coulomb of charge or 3 coulomb of charge, then this seems to be valid. But if I just say 2.5 coulomb of charge like that, right, I actually want to express in this way. Why it is not possible? Because, for example, look, if you just start, look at here, for example, sometimes you say that the babies, let's say, for example, you can only say that there are 2 or 3 babies born in a hospital, but can you say 2.5 baby? Can you say that 3.5 baby came to the world? No. Yeah, for example, if you say about the death in a certain region, for example, you say that due to the COVID-19, there died 20 people, for example, in USA today. So you cannot say that today 20.5 people died. So that is impossible. In the same way, because we can have either a charge or we can have a no charge. For example, where are the charges? Charges could be on the electron. You can have 2 electrons, you can have 3 electrons, you can have 4 electrons. Similarly, you can have 5 protons, you can have 6 protons, you can have 7 protons, right? But you can't have the 2.5 proton, you cannot have 3.5 electron. This is why this is called the quantization of what? The quantization of charge. That it is what? That it must be the integral multiple of a fixed value like this one. Whenever you divide the charge by this value, you will always get a whole number. If you get a fraction number, it means that that is a supposition and it has nothing to do with the experiment. So that is one of the most important aspects of the charge, and this is one of the reasons that the most famous experiment, sometime you might have heard about that experiment, known as the Milken experiment, and he was awarded the Nobel Prize for this contribution, that charges are quantized, that it is the integral multiple of a fixed value, right? Always. So that is the fifth property. The sixth property here of the charge is what? The sixth property of the charge is here the superposition principle. Sixth problem. Superposition principle. The charges obey the superposition principle. Now, what is the superposition principle? The superposition principle tells me that if we have three kind of charges, for example, if we have charge Q1, another positive charge Q2, and if we have another charge, negative charge, for example, Q3. So whatever is the electrostatic force between these two kind of charges, for example, like this is if this is that is charge Q3, so that there must be an electrostatic force between them, and that electrostatic force, the charge, this is the force 1 on 3, and this is 3 on 1. There it is the force which the charge Q1 exerts on the charge Q3. It is the force which the charge Q3 exerts on the charge Q1. Right? This force is the attractive force only. And later on I will be explaining this in a Coulomb law, inshallah, in the next class. So similarly, there is a force between these two also. And this force is the repulsive force. For example, look, this is the force which 2 exerts on 1, and this is the force which 1 exerts on 2. It repels. Similarly, there is again attractive force between these two, like this one and like this. So this is, for example, the force which 2 exert on 3, force, and this is the force which 3 exerts on 2. So the superposition principle, what is the superposition principle? The superposition principle tells you that if you have the body of the 3 charges, so whatever is the force between these two, it will not be influenced by the force between these two. And whatever is the force between these two, it is not going to be affected by the charge 3. Right? So that is called the kind of superposition principle. However, the net force, right, that we can find the total or the resultant force due to any sort of combination. For example, we can find the net force on the charge Q3 due to the charge Q1 and Q2. We call that force as the resultant force. Similarly, we can calculate the net or the resultant force on the charge Q1 due to the charge Q2 and Q3, right? So we can have always a net force, right? But the forces between them will not be affected. The force between these two will not be affected by this charge. The force between these two will not be affected by this charge. And inshallah, when I explain the Coulomb law to you, there it will work best. So the superposition principle you must remember, right? The next important point, since I told you that it is what? That it is one of the fundamental or the basic attribute. So let's see that this charge here, physically it is a scalar quantity. It is what? It is a scalar quantity. It does not have any direction. It is what? It is a scalar quantity. It does not have what? It does not have any direction. And that is the SI unit of this charge. This is same. This is the SI unit is what? The SI unit is Coulomb or Coulomb, right? That is the SI unit of charge. And 1 Coulomb of charge is equal to, that is 1 Coulomb of charge is, we can define it in many ways. You can define this in terms of what you have learned in class 10, that if you remember, that is the most basic in terms of electric current, and you know electric current is what? Q by T. So Q is equal to what? I into T. So you can define 1 coulomb of charge in this way also, that a charge is said to be 1 coulomb if there is 1 ampere of current across the ends of a conductor in 1 second, right? Yeah, a charge is said to be 1 coulomb, right, if 1 ampere of current is maintained across the ends of a conductor in 1 second. So that will be what? That will be a 1 coulomb charge. But here also we can say 1 coulomb of charge is the charge on what? That is, it is equal to 6.25 into 10 raised to the power what? 18 electrons. If there are 6.25 into 10 raised to the power 18 electrons or protons at one place, if they gather around, then they collectively constitute how much charge? 1 coulomb of charge. So if there is a rain of 6.25 into 10 raised to the power 18 electrons coming down, right, it means that there is 1 coulomb of charge. So actually 1 coulomb of charge is a very large unit, though the SI unit, but it is very big, right? Why? Because they look, for 1 coulomb of charge you need these many electrons or protons to constitute 1 coulomb of charge. This is why we always use the submultiple units, the micro coulomb 10 raised to the power minus 6 coulomb, and the nano coulomb and the pico coulomb. So that is what? That is the 1 coulomb of what? That is 1 coulomb of charge, right? So these were all the basic properties of what? The basic properties of the basic properties of the charge. Another important point is which I'll be explaining later on inshallah in the Coulomb law also, that the electrostatic force of attraction or repulsion between charged bodies are greatly affected by the medium. That is by the medium. The force which cause or produced by electric charge can be affected by medium, and inshallah we will be discussing this in our next lecture. So thank you very much. Hope you have learned all the basic about the charges, that what is electric charge and what are the properties of charge, how charges can be reduced. You have learned all these in this lecture. So inshallah see you in the next lecture. In the next lecture it will be a Coulomb law. We will be explaining Coulomb law in great detail.